A very famous formula in math is called the law of cosines. The law of cosines is used to find the missing side of a triangle when two sides are known and the angle between those two sides is known also. In this example, we don't need the law of cosines because if it's a right triangle, we have the Pythagorean theorem, a squared plus b squared equals c squared. In this case, 60 squared plus 80 squared equals x squared, and ultimately x becomes 100. But what if I had an angle other than 90 degrees between the 60 and the 80? Or I had an angle greater than 90 degrees formed by the 60 and the 80 side. Well, in this case, we know the answer is less than 100, but not much more than that. It's almost like you could, and in this one, we know that x is greater than 100, but we don't know much more than that. Well, that's what the law of cosines is going to help us solve. And the law of cosines is going to use the Pythagorean theorem as one of its steps in deriving it. So here's one with an obtuse triangle. And the trick to this question is you can take any obtuse triangle and you could turn it into a right triangle. Well, it doesn't really turn it into, you could add this triangle to it. And now I have a right triangle, which is great, except I don't know the lengths of the sides anymore because the 60 is just from here to here and the 80 is just from here to here. Well, let's examine this red triangle. It's a right triangle. It's got a 60-degree angle because this angle here is supplementary to the 120. And it's got a hypotenuse. This side is the hypotenuse of the small triangle of 60. So that makes this opposite side 60 sine 60. 60 is the angle and 60 is the hypotenuse. Sine 60 is radical 3 over 2, so this is 30 radical 3. So that's the length of this side here. It's also the length of the side of this large right triangle. Now the other side of the right triangle, we know part of it is 80, but we've got this other piece. Well, that piece is hypotenuse times cosine 60, which is just 30. So if I were to remove this red side, what we'd be looking at is a triangle that's got 110 as its right triangle with 110 as its bottom side there, horizontal, and 30 radical 3. And then you'd be able to just do the regular Pythagorean theorem. And you get x is about 122. So that's how you can do it without like a formula. We are going to get a formula for it though. Just to show you that in the other case where this is like less than 90 degrees, still 80 and 60 here, we can do the same trick. This time we'd make an altitude here. And here's our unknown side. So this blue triangle is the right triangle we're going to deal with, that x is the hypotenuse of it. But the sides are no longer 80 and 60. This upright side here is 60, which is the hypotenuse, times sine 60, so that's 30 radical 3, like in that last example. And this side on the bottom here, it's not 80, it's 80 minus whatever this thing is. And that thing is 60 cosine 60, which is equal to 30. So 80 minus 30 is 50. And then we would use this triangle to say 50 squared plus 30 radical 3 squared equals x squared. And x would be less than 100, as predicted, it would be about 72. But let's see how this could be turned into like an actual formula. I'll do the acute case first. let's call, this is lowercase a, this is lowercase b, this is lowercase c. And this is the angle, let's say I'm given this angle, let's call it theta there, angle C is angle theta. So if I do the same trick, I drop this altitude here, I create this right triangle, this one, and the sides of that right triangle, well, I can get those by working out first. This vertical side would be a sine C, whereas this adjacent side would be a cosine C. That makes this side of this green right triangle to be b minus a cosine C. And the upright side from that is still a sine C. And now, because I have a right triangle here, I can do Pythagorean theorem. Now I get a sine C squared, put it in parentheses, plus parentheses b minus a cosine C squared is equal to C squared. I'll use a capital C for the angle and a lowercase c for the unknown thing. When I simplify this, I get a squared sine squared C plus b squared minus 2ab cosine C plus a squared cosine squared C equals C squared. Ran out of room, I'll have to go up here. Now this a squared sine squared C and a squared cosine squared C, we can factor out the a squared from those two terms. I still have the b squared, and I still have the minus 2ab cosine C. But see, this here, sine squared C plus cosine squared C, that equals 1. So it kind of goes away. And what I'm left with is the famous law of cosines. Which is that C squared equals a squared plus b squared minus 2ab cosine C. So that's a formula. And I derived it with the acute triangle, but I could have also derived it with the obtuse triangle, but it's actually a little bit harder. You'll see in a second why. So if I draw in this right triangle here, this is a, so we have this angle here is no longer angle C. So this is a times sine 180 minus C. And this down here is a times cosine 180 minus C. So that's going to complicate things a little bit. Give you a little identity then. Sine of 180 minus x is the same thing as sine x. If I imagine a unit circle, and here's angle x, and then 180 minus x is still there in the same quadrant. On the other hand, cosine 180 minus x is equal to negative cosine x. We can see at least here, if this is x, and this here, all the way around to that point is 180 minus x. The x coordinates are opposite, so the cosine of 180 minus x is negative cosine x. So I'm going to change this to a sine C, but I'm going to change this one to negative a cosine C. Now, the right triangle's sides now are a sine C and b plus negative a cosine C, because this is now negative a cosine C. Cosine's negative, by the way, if you're worried about this thing being negative. Cosine C is negative, so this is actually a positive thing, but still negative a cosine C. When I run this big blue right triangle through the Pythagorean theorem, I get a sine c squared plus b minus a cosine c squared equals c squared. This becomes a squared sine squared c plus b squared minus 2ab cosine c, and then plus a squared cosine squared c. Well, just like before, the a squared is in this term, and in this term I factor out sine squared c plus cosine squared c. Still have the b squared and the minus 2ab cosine c equals c squared. This becomes 1, and again, I'm left with the famous law of cosines. And now that you have the law of cosines, you could use it if you ever see a question where two sides are known and the angle between them is known. You can just say c squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times cosine of the angle that's between them. That will work even if it's whether it's an obtuse or an acute angle. If it's an obtuse angle, the cosine of 120 is going to end up becoming negative, and this will end up becoming a plus eventually, but that's the idea. So that's how the law of cosines works. There's one more thing you can do with the law of cosines. If all three sides of a triangle are known, and you want to know the measure of an angle, you can do that. This becomes the c, and it doesn't matter which one is a and b. So c squared equals a squared plus b squared minus 2 times a times b times cosine x. So that cosine x we're going to solve for eventually. Here's my advice. 100. This is 25 and 49. That adds up to 74. And to simplify this, also it becomes minus 70. Now here's the most dangerous area right here. Don't do 74 minus 70. Instead, because you can't combine these because the cosine x is part of that. Instead, subtract 74 from both sides. Divide both sides by negative 70. And get cosine. It's actually cosine c. Sorry, it is cosine x. So cosine x is equal to negative 26 over 70. You do the, go up here, you got to go to your calculator then, to cosine inverse of regular 26 over 70 to get about 68 degrees. But 68 degrees is not the answer. The answer is 180 minus 68, which is 112, because cosine is negative in quadrants 2 and 3, but we don't bother with quadrant 3 because we can see that it's in a triangle, so it needs to be less than 180. So there's only one answer to that question, which is 112. This question here would have two answers if I needed all the answers between 0 and 360, but I don't. I only need the answers between 0 and 180. And that's the law of cosines.